Hi Physics Honors students. I'm having a little bit of technical difficulty with my computers, but I decided that I was going to go ahead and create a video because right now my computer's locking up with Zoom and there's only two of us, so I figured that I could just create this video. And we're going to talk about currents and resistance. So assignment number 2, I'm asking you on Microsoft Teams to do the practice problems on page 597, and I've asked you to read this on assignment 1. So before you do that, I want to make sure that I go over it with you. Since I thought we would be back by now initially when we first got out, but it looks like I don't think we're going to be back. So let's talk about what is on this page. So we're talking about electric current, okay? So what is electric current? Electric current is the movement of electrons, or as the book says, it's the rate of change that flows through a wire. The rate of change of electrons that flows through the wire. So the SI unit for current is ampere, or capital A, and I know you don't remember way back to 8th grade, but that was one of the first lessons that we learned, was what are the SI units for some things. And we're going to denote this as 1 ampere is equal to 1 coulomb passing through a cross section in time. So if you change that into variables, it becomes 1 ampere is equal to 1 coulomb per second, okay? So when we're talking about current, electric current, we give some variables. Q is going to be equal to the charge, and if it's the charge of the electron, it's going to be QE. I is going to be the electric current, and T is going to be time. So they give us a formula, and the formula is going to be I, so remember that I is electric current, Q is the charge, and T is the time, and that's going to be delta. So it's going to be change of the change of the charge over the change of time. So in the book they say the charge passing through a given area over the time interval is equal to electric current. So you can see that there, it's the same thing, just in words, okay? So I decided to go through example 2 on page 597. So if you have your textbook open, you can look at it, but I'll just read it out for you. In a particular television tube, the beam of current is 60.0 microamps. Now I know I'm going to have to change this because we can't keep that in microamps, okay? And how long does it take for 3.75 times 10 to the 14 electrons to strike the screen? So they also give you a hint. They say recall that the electron has a charge of 1.6 times 10 to the 19 coulombs. Now recall that this is the formula that they gave us in the book. So we're going to have to do some things, and we're going to talk about what we know. But I've run out of paper, so I'm going to move over to another paper. So I'm going to write down what we know. And from this number 2 problem, I'm going to write down my variables. And I know that I is equal to 60.0 microamps. But I don't like that because I'm going to have to change that in order to work the problem out. So I'm going to change this to 60.0 times 10 to the negative 6 amps, which for me, I know you guys try to use this a lot, but I don't like keeping it like that because that's not the exact scientific notation for this. The actual scientific notation to be proper would be 10 to the 6 times 10 to the negative 5 amps. So that's what I'm going to use in my equation right there. Okay, so this is for I. Then they give us N. N is from the hint. N is how long it takes the electrons to strike the screen. So N is going to be 3.75 times 10 to the power of 14 electrons. And I'm just going to use E negative for the electrons. And then they give me Q of the electrons, and the Q of the electrons is 1.6 times 10 to the power of negative 19 coulombs. And that is straight from the problem right there. Okay, so if I use my equation was I is equal to delta Q over delta T. But I'm going to change that because I'm not looking for I am looking for T. I'm looking for delta T. So if I change it for delta T, it's going to be delta T, and to get the delta Q, Matthew just walked in, I'm going to have N times Q of E. Okay, so those multiplied together will give me my Q, my delta Q over I. Okay, So now let's solve them. So my delta T is going to be, so find my N, is going to be 3.75 times 10 to the 14 electrons. And I wrote that really terribly, but I'm so sorry. And my Q of E is going to be 1.6 times 10 to the power of 19 coulombs. And I'm writing very poorly right now. And I had to hold the page to get it down. And then, of course, my I is going to be 6.0 times 10 to the negative 5. Remember, I changed that from microcoulombs. And if you put that in the calculator, you should get delta T is 1.00 seconds. Now, if you're looking for significant figures, you have 2 significant figures in each one of these. So that is what, well, actually, they used 3. So I guess I missed one. Oh, this is 1.60. So they used 3. So that is going to be my answer. Sorry, 1.00 seconds. I miss you guys a lot. I'm praying for you. If you need help, just send me a chat and we can go over things together. Okay, so I'm going to post this video on the class notes section and also in assignment number 2.